Good morning, students. I will take today a revision test, few important sums for exam, because all of you know the annual exam knocking at the door. Okay. Yes. And all of you know the exam is online. Don't see the book. Okay. Don't see the formula. Understood? Yes. So we know you are very well. Our patient students is very well. Yes. Yes. Very good. Now, few sums for revision test, very important sums. Okay, say write down. Revision test. I am taking one question. I am telling. Function. All of you know. Yes. Range of the function, domain of the function. Okay. Few one sums. Write down. Suppose f(x) equal to sin x plus cos x. Find its range. Range of the function. How to find the range? Look at here. So you can write here sin x plus cos x, sin x plus cos x, root over 2 into 1 by root 2 sin x plus 1 by root 2 cos x. Okay? Yes. See here 1 by root 2, so all of you know this will be sin 45 or cos 45 degree. Okay? So write root 2 sin x cos pi by 4 plus cos x sin pi by 4. Okay, so root over 2. So this type this can be written as formula. Okay, so sin a cos b cos a sin b, sin a plus b. Okay, now for all real values of x, that is the least value, the value of sin x always lie between -1 to +1. Okay, so you can write here for all values of x. See, this is the sign of for all values. So -1 less or equal to sin x plus pi by 4 less or equal to 1. See, here root 2 is given. So write root 2 multiplied minus root 2 less or equal to root 2 sin x plus pi by 4 less or equal to root over 2. So this function, this is known as original function sin x plus cos x. So fx. So root over 2 less or equal to fx less or equal to root 2. So this is the range of the function. So here range is equal to minus root 2 less or equal to f of x less or equal to root 2. Okay? Yes. Next one. Look at here. Next one. Suppose fx is given. Suppose fx is given here, fx equal to 1 by 2 minus cos 3x. Find the range of the function. Okay. So for all values, similar way, for all values of x, all of you know. So sin 3x, sorry, cos 3x, always less equal to -1 to +1. See, minus sign is there. So both are multiplied. So it will be changed. So +1 less or equal to minus cos 3x less or equal to -1. Sorry, here -1. See, here 2 add. 2 is given. 2 minus cos 3x. So both the sides 2 add. So 2 plus 1 less or equal to 2 minus cos 3x less or equal to 2 minus 1. So it will be 3 less or equal to 2 minus cos 3x less or equal to 1. Okay, so 1 by 2 minus cos 3 reciprocal is given. So write 1/3. This should again interchange 1 by 2 minus cos 3x less or equal to 1. So this is given the function fx. So 1/3 less or equal to f of x less or equal to 1. So this is the range of the function. Range. Okay. Yes. Again, next one. Now question number 3, right? One important question. Continuity already discussed. Now, a function f(x) has a finite derivative at x equal to a, then the function is continuous. This question is very important question is there. Okay, very important question. The converse is not true always. A function which is continuous may or may not be differentiable, but a function which is differentiable must be continuous. Keep in mind. Very important question. 6 marks question. I will give the exam. 6 marks question. Keep in mind. Okay. Suppose, see, f of x has a finite derivatives at x equal to a. So by definition, all of you know f dot a equal to limit h tends to 0 f of a plus h minus f of a by h. Okay. So this is finite derivative. So we can write here, look at here again, f of a plus h minus f of a by this one we can write f of a plus h minus f of a by h into h we can write now. So now limit h tends to 0 f of a plus h minus f of a equal to limit h tends to 0 f of a plus h minus f of a by h into separate limit. Okay, limit h tends to 0 h. This one is given, see, f dot a finite is given, f dot a given. So write f dot a into 0. So this is finite. So finite into a finite number. Okay, that's the real value is there. So 0 into any finite value is always equal to 0. So write 0. Okay, now we can write, see, so limit h tends to 0 f of a plus h minus f of a equal to 0. So we can write here, we can write here limit h tends to 0 f of a plus h equal to f of a. Okay, now look at here. Now let a plus h, see, a plus h equal to constant x. Okay, x. See, if h tends to 0, then we can write now x tends to a. Yes, so write limit x tends to a f of x equal to f of a. So this can be written as we know, limit x tends to a plus fx equal to limit x tends to a minus fx equal to f of a. What is the condition? So this is condition, it's continuity. So a function which is finite derivative at x equal to a, then we can say the function is continuous. Very important theory, keep in mind. Okay. Okay. Now suppose limit x tends to a e to the power, x tends to right 0 x square minus cos x by x square. How to solve? How to solve? Do it now. Say limit x tends to 0 e to the power x square minus 1 plus we can write 1 minus cos x by x square we can write now. Taking minus 1 here plus 1 both cancel. So you have to separate x tends to 0 e to the power x square minus 1 by x square plus limit x tends to 0 1 minus cos x by x square. So this is one all of you know. and this part will be half. See, so you can write here 1 minus cos square x by x square into 1 plus cos x. So write 1 plus limit x tends to 0. 1 minus cos square x will be sin square x. So write sin square x by x square into, you put the value 1 plus cos x. Cos 0 all of you know 1, so 1 on 2. So this is 1. So write 1 plus half. This is 3 by 2. Okay? Yes. Next. Next one. Limit x tends to 0. So write sin x plus cos x whole to the power 1 by x. Okay, how to solve? So write let sin x plus cos x whole 1 by x equal to a. So take log a equal to 1 by x log sin x plus cos x, you can write no. So 1 by x log, so sin x plus cos x we can write root under 1 plus sin 2x, no. 1 can be sin square plus cos square x, sin 2x, 2 sin x cos x. So it will be sin x plus cos x whole square, root is given. So it will be 1 plus sin 2x. So this part sin x plus cos x. So now log is there. So 1 by x, we can write log 1 plus sin 2x whole to the power half. So half take outside 1 by 2x log of 1 plus sin 2x. Okay. Now so take limit x tends to 0 log a, we can write limit x tends to 0 1 by 2x log